So when we're talking about De Moivre's theorem, okay, let's first go back to multiplying complex numbers. Okay, multiplying complex numbers, right? If they are written in polar form, excuse me, then we multiply the radii and add the angles. So for example, if we have r1 cis theta 1 times r2 cis theta 2, then we multiply our radii, so r1 times r2, and then we have cis of our angles added, theta 1 plus theta 2. Okay? Now, we can have this new lovely idea, right? Let's say z equals r cis theta. Okay? We just found that if we have z squared, that was r cis theta times r cis theta, which actually gives me r squared times cis of 2 theta. What if I had z cubed? Z cubed, I have r cis theta times r cis theta times r cis theta, giving me r cubed cis 3 theta. Okay, let's keep going. What if we have z to the 4th? We have r cis theta times r cis theta, r cis theta times r cis theta, and it gives me r to the 4th cis 4 theta. Noticing a pattern? This is De Moivre's theorem. Okay? And it exactly says the power of a complex number if z equals r cis theta, then z to the n is r cis theta to the n, which is r to the n cis n theta. That is the whole key to the entire thing. Okay? So let's do some examples. Example 1, we want to find 2 cis 30 to the 5. So we know by De Moivre's theorem, this is 2 to the 5 cis of 5 times 30, which gives me 32 cis 150. Ta-da! Now let's do something slightly harder. Find 1 plus I to the 13th. Okay, and we want to express answer in rectangular form. Okay, so we first have to convert our complex number into polar form. So this, we have 1 plus I, which we could write as 1 I hat plus 1 j hat, if it helps you remember, right? This is a remembering. You could write a little memory around it. Okay, so we know that r is going to be the square root of 1 squared plus 1 squared, because 1 squared plus 1 squared equals r squared, which gives me root 2. And I know that the tangent of theta is going to be 1 over 1, which tells me that theta is 45. Okay, we could graph all of this, right? 1, 1 will put us here. Find r and theta. Okay, so we know that 1 plus I, written in polar form, is the square root of 2 cis 45. So, to the 13th power, we will have root 2 cis 45 to the 13th, which becomes root 2 to the 13th cis of 13 times 45. Okay, so this gives me 2 to the 13 over 2 cis 13 times 45, right? Root 2 we just write as 1/2, and then if we have a power raised to a power, we multiply them. That's how I get the 13 over 2, which I can break this down into 2 to the 6 times 2 to the half, cis of 585. Now we still have to simplify. 2 to the 6th is 64. 2 to the 1/2 is root 2. And I can rewrite this as cis of 360 plus 225, which then we know this is 64 root 2 cis of 225. Okay, now it says express your answer in rectangular form, so we need to convert this back to rectangular form. If it helps you remember, this is 64 root 2, 225, and we can draw our graph. We know 225 is over here. We'll have 64 root 2, and then we do 225 minus 180 to be able to find our angle, and we know that our angle will give me 45, and we know that x is minus r cosine theta, which gives me minus 64 root 2 cosine of 45, which I know is minus 64 root 2 times root 2 over 2. Okay, which this will simplify into minus 64. My root 2 times root 2 is 2, divided by 2, makes the 2's cancel. Y is going to be minus r sine of theta, which will be minus, again, 64 root 2 sine of 45, which we know is actually going to give us the same answer because cosine and sine of 45 are the same. So in rectangular coordinates, I'll have minus 64 minus 64i. Okay? All right, now let's move on and talk about roots of numbers. Okay, now an idea that maybe we haven't thought about before is if we were to take the cube root of 8, normally we say that that is 2. But technically, there are 3 roots of cube root 8. We have 2 and we have 2 complex roots. Bum, bum, bum. Okay, so the roots of complex numbers looks a little different. Okay, every complex number except 0 has 2 square roots, 3 cube roots, 4 fourth roots, so on and so forth, and nth roots. So if we were to take the square root of something, it would have 2 square roots. The cube root of something has 3 cube roots, right? Here we have the number 2 and 2 complex roots, which gives me 3 roots because it is the cube root, and so on and so on and so on and so forth. Okay? Now, what we're going to do is we're going to talk about this as complex numbers. Okay? Complex numbers being r cis theta. Okay? And in the roots of complex numbers, the radius is the same. Okay? The angle changes. Okay, so the angle changes. Angles of third roots differ by 360 over 3, or 120 degrees. Angles of fourth roots differ by 360 over 4, which is 90, and so on and so forth. Angles of nth roots differ by 360 over n. Okay? So, I'm going to do an example, and I think it will make this all a lot more clear. I think we're on example 3. We want to find the fourth roots of 16 cis 60. Okay. We can always check our answer. We'll get to that at the end. Okay. So the first root, right, of our radius, okay, is we do 16 to the fourth, which gives me 2. Okay, and then we do 60 divided by 4, which gives me 15. So my first root, I have 2 cis 15. Okay, that's the easy one. Now, angles in polar form, right? Since it is a fourth root, the angles differ by 360 over 4, which is 90. So this is one root. My other root is 2 cis. 15 plus 90 gives me 105. And then we'll have 2 cis 195 and 2 cis 285. We continually add 90 because our differing factor is 90. Okay. Now we can check this by doing 2 cis 15 to the fourth, which gives me 2 to the fourth cis of 4 times 15, which gives me 16 cis of 60. Okay, or we do 2 cis 105 to the fourth, which gives me 2 to the fourth cis 4 times 105, which gives me 16 cis of, this gives me 60 plus 360, which is 16 cis of 60. And so on and so forth. Okay, let's do another example. Find the fifth roots of I. Okay, now we first have to write this in polar form. So right now we have 0 plus I, which if we were to graph that, that's that vector right there. 1, right? So 0 plus I is 1 cis of 90. Now, we're doing the fifth root, right? So our first root will be 1 to the 1 over 5 cis of 90 over 5, which gives me 1 cis of 18. Okay, and then the rest, they will differ by 360 over 5, which is 72. So I will have 1 cis of 90, 1 cis of 162, and 1 cis of 234, and 1 cis of 306. Remember, I should have 5 answers, 1, 2, 3, 4, 5. Okay, and we need to make sure that we check the angles, right? And we can check it by doing 5 times 18, 5 times 90, 5 times 162, 5 times 234, 5 times 306, and making sure that they all add up. Okay. All right, let's do some more examples. Example, I think I'm on example 5, maybe 6, I don't know. Find 2 square roots of 1. Okay, so first we go to the polar form of 1 is 1 plus 0i, which if we were to write it in polar, right, this is the rectangular, this is the polar, is 1 cis 0. So the square root of 1 is we will have 1 to the 1/2 cis 0 over 2, which is 1 cis 0. Okay, and then I will differ by 360 over 2, which is 180. So this is one answer. My other answer will be 1 cis 180. Which makes sense because if we graph this, okay, at 0, we have this vector here, right? And we're finding our complex root, right? It's the other way. Okay, let's do another example. Let's do the opposite. Find 3 roots of -1. 3, excuse me. Third roots of -1. Okay, so we write -1. In rectangular form would be -1 plus 0i. In polar form, this would give me 1 cis 180. Okay, if we go back to this picture up here, right, we know that the cosine is -1 this way. It's the black arrow going this way. Okay. And our first angle, right, we have 1 to the 1/3 cis of 180 over 3, which gives me 1 cis 60. And then we will differ by 360 over 3, or 120. So I will have 1 cis 180 and 1 cis 300. Those are my others. Okay? Let's do one more example. Find 4 roots of 42 cis 40. So my first one, 42 to the 1/4 cis of 40 over 4, which gives me approximately 2.55 cis of 10. And I know that I will differ by 360 over 4, which is 90. So my first one, I have 2.55 cis 10. Then I will have 2.55 cis 100, 2.55 cis 190, and 2.55 cis 280. Okay? That is all for this lesson. Any questions you have, make sure you bring them to class tomorrow.